Well, what's going on, stats peeps? This is Coach Lowe talking to you today. We're going to be going through the intervals. And hang on a second, I'm going to back up to the first screen, would probably be the place to start. And here we go, structure of confidence intervals. So let's take a look. So to create an interval of plausible values for a true parameter, you need two components. The single value estimate. Hang on, let's try to highlight it because this is huge. We'll be talking about this a lot. So the single value estimate is the best guess at what the true parameter is. Okay, it is always the middle of the interval. All right, very important. Single value estimate, always the middle of the interval. Then you're going to have the margin of error. Ooh, a little crazy there. Put your seatbelts on. Here we go, margin of error. What is added and subtracted from that single value estimate to create a confidence interval. So we're going to try to get a window. And in the center of the window is going to be your single value estimate. And what we're going to do is we're going to use this number, the margin of error. We're going to add it. Hang on, I'll just draw it up here. That'd be a good idea. So basically, you're going to be looking at, we know this is what intervals are looking like. We're going to use the brackets with a comma in the middle. So the single value estimate is always going to be in the middle. Okay, and what we're going to be doing is we're going to be plussing the margin of error to get that upper parameter there, and then we're going to be subtracting the margin of error to get the lower parameter. And that's how we get the two bookends, and that's how we get our interval. So single value estimate plus or minus margin of error. Well said. So let's move it on. So a 95% confidence interval for LeBron James's true proportion of three-point shots in 2007-2008 regular season is 0.315. So right here, so we're going to go ahead and nail this down. This is your single value estimate, okay, with a margin of error of 0.049. So this is what we're going to be doing the plus and minus with to get the whole interval. All right, so 0.315 is the, let me see if I can make this neat, single value estimate, which means this is what we believe to be LeBron's true proportion oops, for three-point shots. Right there. Okay, so 0.315 is LeBron's true proportion for three-point shots. And again, going back to the geography, that means that that is going to be basically where the comma goes in your interval. It's going to be that middle number. Okay, so 0.049 is going to be the margin of error. Margin of error, which means, so this is going to go high and low. So you're going to basically add this and subtract this from your single value estimate to get the total confidence interval. So I'll say it another way, which means your confidence interval, let's go backwards there. Confidence interval will exist from 0.049 will be from, actually, you know what, a better way of saying that is within 0.049 of that single value estimate, which was your 0.315. Okay. Let me change color up and show you this. So let's go with crazy orange. Okay. So basically, if we know that 0.315 is going to be the number in the middle, that's your single value estimate. So what we're going to do is we're going to use the margin of error. We're going to get the two bookends up here. Okay, so interval is going to be right there. And then we're going to subtract whatever that margin of error, and we're going to get the lower end of this. Let's change it up. Let's go crazy red. So, all right. So right here we're going to add 0.049. That's the margin of error. That's going to be the top end. And just to help me out a little bit here, let's do this. So we're going to have 0.315 plus 0.049 equals, so we got 0.364 on the top end. And we're going to do the same thing going to the bottom end. So we're going to do 0.315 minus whatever that margin of error was, 0.049, so 0.266. And there you go. Take that right over here. So basically your confidence interval is going to be 0.266 comma 0.364. Okay, so that's going from the ground up to get your interval. On the next slide is going to be a different look. This time we're going to go backwards. Here we go. A 95% confidence interval for Ryan Miller's USA hockey goalie. True proportion of save goals, okay, during the 2009-10 regular season is 0.918 comma 0.940. So they're going to give you the whole interval. So this is your confidence interval. Okay. Oops, I hit the button. This is your confidence interval. That's awful. I'm erasing that. That looks bad. We got standards. So hey. Well, yeah, it's awful. All right. So that's our confidence interval. So let's go back here, change the color up. Let's just go gray, like the weather, gray. So calculate the single value estimate. So now here we go. If I draw the interval out over here, I'm giving a little render right. We got 0.918 comma 0.940. Okay, so we got the two bookends for the confidence interval. We want the middle. We want that middle ground right there, that single value estimate. So let's come over here and let's do a quick average. So we're going to do 0.918. Come on, Ms. Cole. Plus 0.940. And then whatever you get, you're going to divide that by 2. So what's that going to get you? Wrong button. Let's go this one. So basically, let's try this. We're going to get 0.918 plus 0.940 equals, and whatever we get, let's divide that by 2 because we're going for the average. So 0.929. So we got 0.929. So that is going to be the single value estimate. That's going to go right there. That's right there in the middle. Okay. Now, let me change the color up a little more. So if that's a single value estimate and it's right in the middle, how are you going to get that distance from the single value estimate to the upper and lower parameters here? So what I usually do is I start with the higher one, 0.940, and just find the distance, subtract it, 0.929, and that's going to give us the distance. So here we go, hit the right button. So we got 0.940 minus 0.929 equals, so 0.0. All right, so 0.011. This is going to be the actual margin. Okay, so 0.011, which means from that single value estimate right here, you would plus 0.011 to get to the upper end, and then you would subtract 0.011 to get to the lower end. So basically, to write it out, Start here with single value estimate, so 0.929 plus or minus whatever your margin of error is, 0.011. Okay, and that's how you get it. All right, peeps, what you think? That's a scary looking cloud. So I hope you're doing all right out there in stat world. Stay dry, stay warm. I think it does. Sun comes out Wednesday, so keep it up, guys. Okay. I appreciate it. Let us know if you have any questions.